For 2 decades, users navigated the web by browsing ranked lists of blue links. Today, that behavior has collapsed into a single interaction, asking a question and receiving an instantly synthesized answer. This animated diagram contrasts the old and new web. On the left, a traditional search results page, a vertical stack of isolated links. On the right, the new reality, a single consolidated block of text mapped to small interconnected citation nodes. The metrics that dominated the left side, search volume, keyword density, and page rank, do not translate to the right. Large language models, or LLMs, are AI systems trained to process and generate human text. They do not read and index websites the way a traditional search crawler does. Instead, they retrieve specific, fragmented data points and synthesize them on the fly. Surviving this architectural shift requires a new standard, Generative Engine Optimization, or GEO. GEO is the practice of structuring digital content specifically so that AI models can easily retrieve, understand, and cite it. This is a rigorous data engineering challenge. It requires packaging a brand's assets into precise, machine-readable formats before competitors capture the citation space. This visibility dictates success across the entire modern answer stack: ChatGPT commerce surfaces, DeepSeek provider APIs, Google's Gemini ecosystem, and Perplexity's answer engine. Managing this across multiple models requires specialized infrastructure. Trajectory is an AI visibility operating system built exclusively to audit, measure, and execute GEO workflows. Survival in the AI search stack means abandoning speculative SEO hacking. Success now relies on measured, closed-loop technical execution. Every technical diagnostic begins with the reality of the open web: raw, unstructured HTML pages that AI models struggle to parse reliably. This diagram shows the transition from a traditional index to an entity graph, a structured model mapping concepts and their relationships. Building this requires inspecting schema markup, auditing feeds, and enforcing canonical hygiene, designating a single authoritative URL to prevent confusion. A brand's entire product family architecture must be structured logically. If the hierarchy is clean, the LLM can accurately parse the relationships. This audit phase results in an objective score, determining precisely whether products are actually machine-readable. A fully mapped, perfectly hygienic data structure is the absolute prerequisite. Without entity clarity, subsequent attempts fail, and foundational data remains invisible. To test this legibility, the system deploys active prompt cohorts across the major AI engines. These tests cover comparison queries, recommendation requests, persona-based searches, and complex problem-solving scenarios. The evidence generated by these prompts flows back into the system through 2 distinct data streams. This verification loop illustrates 2 streams approaching a central filter. The first is pure API-level truth passing into an isolated measurement bucket. The second is synthetic fallback, browser-based UI evidence, actively diverted into a separate area. A red warning triggers if they mix. Mixing these data classes corrupts the metrics. It confuses true systemic visibility gains with low-quality, temporary browser evidence. Honest measurement in GEO is only possible when the data pipeline actively prevents interface artifacts from polluting reality. Once internal data is verified, focus shifts to deploying corrections across the wider digital ecosystem. This source portfolio diagram shows a central brand node orbiting external trust layers, like GitHub, Docs, and Feeds. The radar sweep scans this orbit for missing connections, highlighting an external node connected to a competitor as a target. It then pinpoints the exact specific prompts where a brand unexpectedly disappears from the AI's output. Simultaneously, it locates missing owned sources that the LLM already trusts but aren't connected to the brand. This data drives a geo-gap analysis, an execution framework designed specifically to target these weak trust layers. The output becomes a strict queue, drafting social content, scheduling updates, and targeting review-first public services. Continuous monitoring is required to detect contradicted claims within new answer outputs, preventing the brand from regressing. Fixing AI visibility requires an active, ongoing campaign of deploying trusted evidence. The entire operational lifecycle of AI visibility functions as a single, unified workflow. This macro-level flowchart maps the complete closed-loop architecture. Data flows continuously between 6 distinct modules: audit, verify, capture, act, publish, and measure. All previous system actions and diagnostics roll up into a single trackable metric, the blended benchmark score. Project-scoped audit reports capture this data, tracking exact benchmark differentials over time. If visibility drops, the system's automated regression feature instantly reopens recommendation workflows to correct the drift. The ultimate defining metric of success is the tracked percentage of owned source citation coverage across all observed prompts. Generative Engine Optimization is a measurable data engineering challenge requiring constant systemic oversight. The stakes of maintaining machine legibility are absolute. Brands must systematically structure their source portfolios and monitor model surface risk through a dedicated operating system, or their competitors will permanently own the answer.